Hello everyone, welcome to Vedantu J English. I am Diksha Kaushal, your chemistry master teacher. So everybody in the chat box, do let me know how are you all and how is your preparation going on. Yes, everyone in the chat box, do let me know how are you all and how's your preparation going on. And guys, we have successfully completed coordination chemistry and chemical bonding. And today we are going to do block chemistry, right? So in block chemistry, I'll do theory part as well, but theory will be like a very rapid revision, right? But after that, PYQs is the main goal that we are going to focus on, especially 2026 PYQs, right? Okay, so yes, everybody, do let me know if that is clear and you can't see me. Is it? Diksha Ma'am, where are you? Okay, I'm so sorry. Like something happened to the this camera and I became a ghost suddenly. Right? I think ma'am is adjusting the camera. No, I was not adjusting the camera. I think the video got stuck in between, so that's why not visible to you, and I looked like a ghost to you. Right? My only voice you could hear. Right? Okay. So very good afternoon, students. Let's start today's class. And as I told you, what we are going to do today, we are going to do P block, DNF block, periodic properties. I'm going to just do rapid revision of theory part, some of the important exceptions of theory. And after that, we are going to jump to the previous year questions. Okay. Yes, everybody. Is that clear? Are you all ready for that? Are you all ready for that? Yes, students, are you all ready for that? Do let me know in the chat box. Let's rock chemistry and finish this thing off. Yes, let's do that. Let's do that. What is happening here? Wait a minute. Okay, I think it should not create a problem now. Right? Okay. PYQ's maximum effort. Yes. So, firstly, I'll just go through the theory part here. Right? Now, guys, block chemistry I'm teaching you like in just one go. So, first thing you should know that what is exactly how periodic table looks like. So, I'm not giving you any mnemonic here because as of now, just 10 days before, you should not learn this with a new mnemonic. You should learn all the groups and periods with the old mnemonics that you already know, right? So this is S block, right? And this one accounts for D block and this one is for P block, right? When I talk about S block here, in the S block you have two groups, group number 1, group number 2. In D block you have total group number 3 to group number 12, you have your D block. In total you have 10 groups here in the D block, right? And in P block, you talk about group number 13 to 18. These are total 6 groups that you have here. And that is the reason in S, the maximum electron filling is 2. In D, the maximum electron filling is 10 because it has only 10 groups. In P, the maximum electron filling is 6. And when we talk about F block is in between the transition elements that we call D block, right? So this is the D block here, right? That's the D block, and in between the D block, you will have the F block here. That means after lanthanum, and this is actinoid, here you will have the inner transition elements. Okay, D block is the transition elements, and in between what will happen, what will start happening here, after lanthanum you will start filling 4f orbital. So this will become 4f1, 4f2, 4f3, 4, 5, 6, 7, 8, 9 and 10 should be there, right? So after that you will start filling 14 electrons actually, 9, 10, 11, 12, 13, 14. Okay, so that's how you're going to go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. right? So total how many electrons? 4f 14 electrons you are going to start filling here. From here also you is going to start filling 5f orbitals, right? Now this accounts for a very, very important thing that is called, oh, what is this, yaar? I hope so. After this, it should not glitch actually, because all the things are perfect here, right? But still, I'll just look at if it is still glitching, I'll see what I can do about it. Okay. Yes, you focus here. Now, I'm in the starting only. I'm telling you about 2-3 concepts here, so that the exceptions and everything becomes easy for you. So first thing is, you should see that here in this case, this is d orbital, right? And here I am saying this is lanthanoid and this is actinium, this is lanthanum, this is actinium. Here you are filling 4f orbitals, right? If I talk about the shielding effect, firstly I am talking about the shielding effect. Shielding effect means to protect, right? S has maximum, then P, then D, then you have F. So what we are saying, if this is the nucleus, okay, if I say this is the nucleus and here is the outermost electron that you have, right? Now we know that nucleus is positive charge, electron is negative charge, so there will be attraction here. Electron will be attracted here, right? That is attraction from the nucleus to the electron, right? Now if I say in between I have some big orbitals that are protecting that this outermost electron should not get attracted here, right? This is what we called shielding, right? What I'm saying, that you have this nucleus over here and this is the outermost electron, right? Outermost electron will get attracted here, but for example in between you have some orbitals, some inner core orbitals that are shielding the outermost electron from the nucleus. That is called as uh, actually shielding effect. Okay, now this shielding is very good in case of S. If you have inner core electron orbitals as S orbital, they protect the outermost electron very in a very good way. If you have D block, right, D orbitals, they don't have very good shielding effect, right? And F block has the poorest shielding effect. That means F orbitals are not able to shield the outermost electron to this nucleus. That means this inner core orbitals, F orbital, are not able to protect this electron from the nucleus. So this electron will easily get attracted to the nucleus and hence the size will shrink here. And this is what we call as lanthanoid contraction. We say because of 4f orbitals here, what will happen, the size of this series, lanthanoid series, is going to decrease because the outermost electrons are going to get attracted to the nucleus. Okay, this is what we call lanthanoid contraction. Okay, lanthanoid contraction. Similarly, in this case you have 5f orbitals, so that will be actinoid contraction that we will talk about. And we say that lanthanoid contraction is poor as compared to actinoid. See, shielding effect of 5f orbital is even poor as compared to 4f orbital. That is why actinoid contraction is stronger as compared to lanthanoid. That means we are saying that 5f orbital is even poor in shielding. That is why the size will further shrink. So in actinoids, the size will be further less here, right? Okay, tell me, is this thing clear to everybody? That is lanthanoid contraction, and lanthanoid contraction is going to give big effects here. Now, in this case also what you will see, that before aluminium, now I'm giving you another example of shielding effect that can affect the that will form the exceptional cases here. That is inert pair effect. First is lanthanoid contraction, other is inert pair effect. These two effects will govern the exceptions here, right? So if I talk about inert pair effect, what will happen here? See, before gallium, you have 3D orbitals that are being filled, right? Before aluminium, you don't have 3D orbitals that are being filled here, right? So what will happen? What will happen? D orbitals does not have good shielding effect as compared to S orbitals. So that is why you will see so many abnormalities in the size, ionization, enthalpy here, right? So in general, what happens, I'm also writing here in general what happens, okay? I'm just writing in general what happens here. Down the group, what should happen? Size should, atomic size should, radius should increase. Ionization enthalpy should decrease, electron affinity should decrease, electron negativity should decrease. This should happen in general, right? So what we can see here, what should happen here, that from boron to this thallium, the size should increase here because it is down the group. But in reality, that thing will not happen, and you will see so many abnormalities here. In the group 13, maximum abnormalities you will see. Why? Because of this 3D electrons, 3D orbitals that have, this has 3D orbitals filling, that has poor shielding effect. Because of the poor shielding effect of 3D orbitals, right, that is called as inert pair effect, right? It is going to cause abnormalities in 13 group and 14, 15 and so on, right? Okay, tell me. All that is because of the shielding effect, that goes like this: S, P, D and F, right? Okay, tell me. Is that clear? Is that clear? Is that clear, everyone? I think I need to see what is the issue with the OPS, right? I'll see it today. I'll talk to the team about it, right? Okay. Now let's talk about further things here. That is the trends. Now, if I talk about the period and the group, and I am here talking about the basic strength and acidic strength of the oxides. So what we will see along the period means this way, down the group means this way. Along the period, the acidic strength of oxide increases. I'll tell you simply, right? If you go like this, right, what will happen along the period, this is metallic, this is non-metallic. So non-metallic character will increase along the period, not group. If I am talking about in the group here, metallic character is going to increase. So metallic character will increase along the group, right? And non-metallic character will increase along the period. So when I talk about period, non-metallic character increases. Non-metallic character means acidic strength. So acidic strength also increases. Basic strength is inversely proportional to that. In the group, if here non-metallic character increases, in the group metallic character increases, that means basic strength increases. That means acidic strength decreases, right? So accordingly, you can see sodium, potassium, rubidium and cesium. This is group number 1, right? In this case, that is down the group. Okay, that is down the group. So in the group, what happens to the basic strength? That increases down the group, as you can see. This is actually, again, this is down the group only. And what we say down the group, if I talk about the acidic strength here, acidic strength will decrease, right? So here down the group, acidic strength is decreasing here, right? Okay. Next is oxides of same element. Oxides of same element, if I say, acidic strength is directly proportional to, very important. If I talk about the same element and different oxides are there, then I'll say oxides depends upon the number of oxygen atoms that you have, and it is inversely proportional to the central metal atom, right? So just directly see, it is directly proportional to the oxidation state. More is the oxidation state, more will be the acidic strength here. So that ways we can see this here. We can see this here. This is SO3. This has you can say X minus 4. So this will be plus 4. This will be plus 6. Oxidation state. So more is the oxidation state, more is the acidic strength. Similarly here, this is equals to plus 5 here, and this will be equals to plus 3 here. So that is why more is the oxidation state, more is the acidic strength. Similarly here it is plus 2, right? And this is, you can say 2x minus 6, that is plus 3, right? And here it is, wait a minute, this should be x minus, this should be plus 4, okay? This should be plus 2. And more is the acidic strength, more is the oxidation state, more is the acidic strength. That is why this is the value, this is the order of acidic strength here, right? Okay, done. Metal oxides are basic in nature. Then how MgO is acidic in nature, ma'am? MgO, where is MgO? I have not written MgO. This is Mn. Manganese, bacha, this is manganese, not Mg. Okay, right? Have I anywhere written Mg? This is what we are saying, na? This is, we are telling the acidic strength. This is more acidic as compared to this, right? Okay? Yes. Now, next is atomic radius. If I talk about the atomic radius here, in the period 1, period 2, in the group 1, group 2, no, it is along the period only. Wait, this is along the period only, right? So I'll just mention here. Yes, this is period 1, this is 2, this is 3. What will happen? Let's talk about this, right? So if I talk about this thing here, it will be first is hydrogen and helium. Now helium has van der Waals radius, so definitely it is going to have more radius here, right? Talking about the second group here, lithium, beryllium, boron, carbon, nitrogen, oxygen. So this is along the period. Down the group size will increase, along the period size will decrease here. So size is going to decrease from lithium, then beryllium, then boron, then carbon, nitrogen, oxygen, fluorine. Size is decreasing here. But noble gases has the maximum size here, right? That is why noble gases will be in the front of it. Noble gases will be in the front of it. Noble gases has maximum size, and after that you can start from group number 1 till n, you can say. That means out of this, neon has maximum, then lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Here also argon has maximum, then sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. Okay, that's how you're going to do this along the period here. Then we talk about ionization enthalpy, and very important trends here of ionization enthalpy. Let's talk about that. So ionization enthalpy, if I say along the period, right, now what exactly happens here, right? The irregular trends are found in second, third and fourth period, and in a very similar way they are found, right? How they are found? If I talk about expected trend is that along the period ionization enthalpy should increase, that I told you here, right? A very simple thing I told you here, that down the group ionization enthalpy decreases, so along the period it should increase here, right? And that is the reason it should be something like this. It should be something like this: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. But in reality something different will happen in case of beryllium and boron, in case of nitrogen and oxygen. What is the reason behind that? See, in case of beryllium, what you have, 1s2, 2s2, 2p1. Okay, in case this is hydrogen, helium, lithium, beryllium. Okay, this is 2s2, right? And this will have 1s2, 2s2, 2p1. Okay, so you can clearly see that in this case beryllium has a very stable configuration of fully filled s orbital, right? Whenever something is fully filled or half filled, it is extra stable, and it is very difficult to take out electrons from something which is extra stable. That is the reason beryllium will have more ionization enthalpy as compared to boron. Similar cases for nitrogen. Nitrogen is 1s2, 2s2, 2p3, and oxygen is 1s2, 2s2, 2p4. Now in this case as well, you can see p orbital is half filled here, right? Here it was this much. Now here p orbital is half filled, that provides it extra stability. So because of that extra stability, it is very difficult to take out electrons from nitrogen, right? And that is the reason nitrogen has more ionization enthalpy as compared to oxygen here, right? Okay, that is the thing. So that is why this will become your formula here. That is why this will become your formula here, right? Okay, so here beryllium has more and nitrogen has more. So that is the exceptional cases. On the similar line, magnesium will have more as compared to aluminium, and phosphorus will have more as compared to sulfur. On the similar line, you will have, wait a minute, yes, calcium will have more as compared to gallium, and arsenic will have more as compared to selenium, right? That is why there is irregular trend that you observe in second, third and fourth period, right? Okay, tell me, is that clear? Now next is electron gain enthalpy. In electron gain enthalpy, usually it is not asked, but still, because in first attempt very weird exceptions were asked, so that is why I am going to give you this as well, right? So in this case, what you will see, a very weird electron trend will be observed. So here firstly you will have electron gain enthalpy. Hydrogen will have more as compared to helium. Then here the trend will be fluorine, oxygen, then carbon, then lithium, boron, nitrogen, beryllium, and then neon will have, right? So always remember, noble gases always have minimum electron gain enthalpy because they are already very stable. They don't want to gain any electron here, right? Then guys, in this case as well, you will have chlorine, then sulfur. That means exactly you can remember it like this. This is group number 17, then you have group number 16, right? Then you have group number 14, right? Then you have group number 1, right? Then you have group number 13, right? Okay, then you have group number 15, then you have group number 2, then you have group number 18. So that is how you can remember, so that you don't have to remember it individually, right? Either you can remember two trends or you can just remember this part here. Okay, that is what we have. That is 17, 16, 14. Okay, decreasing 17, 16, then skip 15, 17, 16, 14, right? Then 1, then 13, 15. Here we were left with 14. After that there was 15, 13, and this was 15. So 13, 15, then you have 2, then you have 18. Okay, so you can remember this way. Okay, so what I am telling you here, see, 17, then you write 16. Okay, 15 will be somewhere else, right? Then you write 14, then you write 1. After 1, connect the missing dots. Here missing was 13, so I'm going to write 13 here. Here missing was 15, so I'm going to write 15 here. And after that, again this missing was, next to this was 2, and then it was 18. Okay, just remember this one, okay, so that you don't have to remember this one and this one individually, right? That is the trick for electron gain enthalpy. Then if I talk about some important points here, third period move affinity, more electron affinity than second period. So we are saying that third period will always have more electron affinity as compared to second period, right? Why? Because of the smallest size, extra electron and repulsions here. Down the group we know that what is happening in down the group, I'm saying along the period what is happening, the size is decreasing here. That is why third period will have more affinity as compared to second period. Now exceptions are second period and third period. If you see, exceptions are, in this case, this so we have written it already, na? We have done it already, isn't it? This we have written already, right? This we have done already. Then atomic radius in S block, what we have, right? Lena, Key, Ruby, say friendship, direct, there is no abnormality here. Beryllium, magnesium, calcium, strontium, barium, radium, there is no exception in this case. No exception in this case. It is quite simple, right? Okay. Yes. Now, let's talk about group number 13. So, in group number 13, what you have, everyone? In group number 13, what you have? Yes, phosphorus belongs to group number 15 only. That's what we have written here. Nitrogen belongs to group number 15, right? Now let's talk about the valencies, the very important group-wise distributions here. So in group-wise, this is about group number 13, right? That is beryllium, beryllium, I'm saying boron, aluminium, gallium, indium, thallium, right? So actually it is bal, gaye, Indian, te. Okay, or you can say baggot. You can also remember it by baggot. Boron, aluminium, gallium, Indian, thallium, baggot. Now what you will see, the atomic radii, as I told you, what is the reason behind their exceptional cases? That is due to poor shielding effect of d orbitals, inert pair effect that I have already told you. Now we will see what is the exceptional cases that you will have. Atomic radii is, this will follow, it is supposed to be down the group, it is increasing, so it should be boron, aluminium, gallium, Indian, thallium. It is actually boron, gallium, aluminium. So that means here you can see the exception. According to this, aluminium should be more as compared to, wait a minute. According to this, it should be aluminium, then gallium should be more. But in reality, you have aluminium more and gallium less. That is because of inert pair effect. That is the exception here, right? Then ionization enthalpy follows a very different trend that you can remember by this W, right? That you can remember by this W. This is BAL, BALGAINTL. So it will be boron, thallium, gallium, aluminium, indium. Okay, that's how you remember this. Very, very important. Right? Then you have electronegativity here. In electronegativity, how it is? Boron, then thallium, then indium, gallium, and then aluminium. Right? Oxidation state, if you see, the general electronic configuration is Ns to Np1. So total 2 plus 1 plus 3 is the higher oxidation state, and only plus 1 is the lower oxidation state. That means the one that is in the p orbital, that is a lower oxidation state. So you have oxidation state plus 1 and plus 3 here. And always remember, in any group you see, lower oxidation state stability increases down the group. Okay, so what I am saying, lower oxidation state stability increases down the group. Down the group, its stability will always increase. That means down the group, these all will be stable in the plus 1 oxidation state, right? Then metallic character increases down the group. Melting point is, you can see, it decreases up to gallium and then suddenly it increases. So gallium has the lowest melting point that can even melt in our palm, right? Then boiling point decreases down the group, density increases down the group. Okay. Now reactivity with air, reacts with air to form oxides, right? And nitrides also. Crystalline boron is unreactive, amorphous boron reacts here, aluminium form oxides later and does not react further. Okay, crystalline boron is unreactive, amorphous boron is reactive here. Boron does not react here, we are saying reactivity, the acid and aluminium reacts with both acids and alkalis to liberate hydrogen gas. We are saying that boron does not react, boron will not react here. But aluminium reacts with both acids and alkalis to liberate hydrogen gas. Aluminium is passive with concentrated nitric acid. Okay. Then reactivity with halogens. It reacts with halogens to form trihalides except triiodide of thallium, that is TLI3 does not exist only. This is very important. Which of the following does not exist? Boron is acidic, the oxides, trioxides of boron is acidic, aluminium and gallium are amphoteric, and indium and thallium are basic in nature. Okay, this is all the tables that you have. So I'll just tell you some important lines of NCERT as well here. Gallium with unusual low melting point. Gallium has low melting point. It can also melt in our palm. Could exist in liquid state during summer. It has high boiling point, makes it useful material for measuring high temperatures. They can ask you which is the useful material for measuring high temperature. That is gallium. Due to small size of boron, the sum of first, very important, why boron forms covalent compounds. Question is why boron forms covalent compounds? Because due to small size, the sum of first ionization enthalpy is very high. That is why plus 3 ions, it is not B3 positive, does not exist. Because first three, to lose 3 electrons, it is very difficult. The ionization enthalpy is very high. That is the reason it forces it to form covalent compounds. Okay, so question is why boron forms covalent compounds, right? Then boron is unreactive in crystalline and in amorphous state it is quite reactive. Aluminium forms very thin layer of oxide on the surface which protects it from the metal surface. Amorphous boron and aluminium metal or heating in air forms these two oxides. Okay. With dinitrogen at high temperature, they form nitrides. The nature of these oxides varies down the group. Boron trioxide is acidic, reacts with this to form metallic borate, that is okay. Aluminium and gallium are amphoteric, and those of indium and thallium are basic in nature. Okay. So all of this I have also written in this tabular form. Boron is acidic, aluminium, gallium is amphoteric, indium, thallium is basic in nature, right? Then you have group number 14. Okay, then you have group number 14. See, I am giving you some specific important points here for your just quick revision here, right? If you see atomic radii here, that is going to be what? In the atomic radii, it should be Ka, Si, Gaye, Sant, Prabhu. That is as it is, there is no change, there is no exception. In ionization enthalpy, it should be down the group. Ionization enthalpy is decreasing. So it should be Ka, Si, Gaye, SN, PB, tin and lead. But it is actually opposite of that. So here we can see an exception in this case. Electron negativity, very important. Calcium has calcium, I'm saying carbon has maximum, then you have lead. After lead, silicon, germanium and tin have the same electron negativity. Oxidation state, general oxidation state is +2 and +4. Stability of +2 oxidation state increases down the group due to inert pair effect. We are saying that due to inert pair effect, right, the stability of +2 oxidation state increases down the group. Now, what are the oxidation states? Either here it will be NS2, NP2. So lower oxidation state is +2 and higher will be +4 here. And we know that lower oxidation state stability increases down the group. Metallic character simply increases down the group. Melting point decreases up to 10 and then it starts increasing. Boiling point decreases down the group. Density is simple. Firstly carbon, then silicon, then germanium, then tin, and lead it will decrease here. And catenation property is shown by, that is self-linking property, maximum with carbon, then silicon, then germanium and tin has almost minimum negligible, and PB has no catenation tendency. Lead has no catenation tendency, right? With talking about the chemical reactivity, with air they react to form monoxide in like carbon monoxide, carbon dioxide, silicon dioxide. Okay, these things they form. With water, very important, only tin reacts with steam. Rest all do not react with any form of water. Only tin will react with the steam. Then reactivity with halogen, they form dihalides and tetrahalides with the halogens, right? Okay. Catenation properties we have seen, that is the self, due to property of catenation, p-pi bond formation, carbon is able to form, show allotropic forms, that is it is able to form uh, diamond, graphite, and Buckminster fullerene, different structures of that, right? Now, if I talk about the bond enthalpy here, down the group you can see carbon has strongest bond, very good bond strength is there. Then down the group what you will see, the bond enthalpy is decreasing. That means bond strength is decreasing here. Because bond enthalpy is decreasing, that means bond strength is decreasing down the group, right? Then this is quite important. Then they say the central metal atom in these halides undergo sp3 hybridization. Molecule is tetrahedral in shape. Exceptions are SNF4 and which are ionic. Now they will ask you that group 14 element, there are some halides that are ionic in nature. What are those halides? So those halides are PbF4 and SNF4. Okay, these are directly from your NCERT only. PbI4 does not exist because PbI, now we are saying that lead iodide does not exist only, right? Why? Because PbI, they can ask you a Xerschen reasoning question on that, because PbI bond initially formed during reaction does not release enough energy to impair 6s2, or you can say unpair 6s2 electrons and excite one of them to higher. So basically what they are saying, that if you want to have this kind of situation, it should be ns2 np2, right? So it should be ns1 np3, okay, so that all the electrons are unpaired, so that they can, all the electrons, 4 orbitals are half filled, so that all these orbitals can form 1-1 bond to make 4 bonds here. So for that you need to unpair this ns2 as well, that means 6s2 as well. For that you should have some external energy here, right? In all the other bonds, what happens, as soon as one bond is formed, like this is carbon iodine bond is formed, it releases enough energy so that you can unpair this ns2, right? But in the case of PbI, it does not releases enough energy to unpair the 6s2, and that is the reason, right, we are saying that this does not exist only because 4 unpaired electron does not exist here, right? Then reactivity towards oxygen, they form monoxide and dioxide respectively. Now SiO, that is silicon monoxide, only exists at high temperature. Oxides in higher oxidation state of elements are generally more that means more is the oxidation state, more is the acidity. So according to the dioxides, carbon, silicon and germanium are acidic. Tin and lead are amphoteric in nature, right? Okay. But if I talk about monoxides, CO is neutral, carbon monoxide is neutral, germanium oxide is acidic, whereas tin and lead is amphoteric in nature here. This is about the nature, and from the nature of oxides also they ask you a lot of questions, okay? We are going to do that, okay? Don't worry. Covalent radius, if I talk about the covalent radius, right, this we have discussed. That what about the covalent radius on ionization enthalpy, this we have discussed. Now let's discuss group number 15. Group number 15 again, guys. In this case, atomic radius, you can see this. Arsenic to bismuth, only a small increase in covalent radius is observed. So what you can see here, in the case of covalent radius here, wait a minute. This is the basicity order. Yup. Chalo, let's see this only here, right? Then electron negativity is of this order. I am just doing a fast rapid revision because everything is written here, right? Then you have melting point. This is the order. Boiling point increases from top to bottom, and density increases up to arsenic, decreases up to bismuth. Now in this case, there is one more oxidation state that is quite famous, that is -3. Otherwise, it should be NS2, NP3 plus 3 and plus 5 should be the oxidation state. But there is one more oxidation state that is due to the electron negativity of these elements, and that is nitrogen, phosphorus, arsenic, then you have antimony, and then you have bismuth. Okay, that is how it will be. Down the group it is going to decrease. Now physical properties are all the elements are polyatomic here. Dinitrogen is a diatomic gas while all others are solids. Boiling point increases from top to bottom. Melting point increases up to arsenic, then decreases up to bismuth. Metallic character increases down the group. Except nitrogen, all other elements show allotropy. Nitrogen will not show any kind of allotropic behavior here. Next is from hydrides. They ask you a lot of questions based on the melting point order, boiling point order. Then they ask you based on the thermal stability, bond association enthalpy. So what you can say, thermal stability of then nitrogen, then phosphorus, then arsenic, then antimony, then bismuth. It is like this. It decreases down the group. And acid reducing characteristics or acidity, right? That will be increases down the group. Basicity will also decrease down the group. If thermal stability is decreasing, so that means bond dissociation enthalpy should also decrease down the group, because this is least stable, so it can easily be dissociated here. Right now, if you talk about the boiling point, that is of the order, firstly, this is very important, that it should be like, it should increase down the group. So NH3 should have minimum boiling point. But because of this question is asked so many times, because of the hydrogen bonding of NH3, it is lying in between here, right? Then basic character I told you here only, it is same as thermal stability. Okay. You can also write the order of melting point here, right? Okay. That will be same. First is pH3, then you have ASH3, then you have SBH3, then maximum will be, wait a minute, this is increasing now. Wait. Firstly, you have phosphorus, arsenic, antimony, then you have nitrogen. This is the melting point order. Okay? So they can ask you boiling point, melting point, anything, right? Basicity decreasing in order. Now this they are saying basicity is decreasing in this order, right? Due to high electronegativity in small size of nitrogen, NH3 exhibit hydrogen bonding in solid as well as liquid state. Because of this, it has higher melting and boiling point than pH3. Right? Why NH3 is higher? It is not supposed to have that, but it still has because of hydrogen bonding. The oxide in higher oxidation state is more acidic, that we know. Their acidic character decrease down the group. The oxide of this type of nitrogen and phosphorus are purely acidic. That means Ne2, then you have P2O, right? N2O or P2O, they are purely acidic. That of arsenic and antimony are amphoteric, and those of bismuth are predominantly basic. So this is about the oxides. Okay, this oxides, nitrogen and phosphorus, that are acidic, arsenic and antimony are amphoteric, and those of bismuth are predominantly basic in nature. Now arsenic to bismuth, if I talk about, right, now in this case you have arsenic to bismuth, only a small increase in covalent radius is observed. This is due to presence of completely filled d or f orbital in the heavy element. So what we are saying, as you say, arsenic to bismuth, they are saying very small increases there. Here you have large increase and here you have very small increase. Why? Because presence of completely filled d or f orbitals in the heavier metal. So here you have completely filled orbitals, that is why very small increase is observed here. Much greater group 14 due to extra. Now they are saying group 14 due to extra stable half filled. Okay. The ionization enthalpy, we are saying the ionization enthalpy of group number 13 elements are more than group number 14. because this is, wait a minute, not this. Wait a minute. Group number 13, 15 has more as compared to group number 14. This is 15 now. So group number 14 is NS2NP2. This is NS2NP3. So because of its half-filled stable configuration, its ionization enthalpy is quite high. Except nitrogen, all others show allotropy here, right? Talking about the oxidation states, all oxidation state +1 to +4 tend to disproportionate in acidic medium, like here it will disproportionate. In case of phosphorus, nearly all intermediate oxidation state disproportionate into +5 and -3, both alkali this. Both +3 oxidation state in case of arsenic, antimony and bismuth become increasingly stable with respect to disproportionation. So we are talking about disproportionation reactions here, that nitrogen will disproportionate into +1 and +4, and if I talk about phosphorus, it will disproportionate into +5 and -3, but arsenic, antimony and bismuth, their +3 oxidation state is stable, so it will not disproportionate. Okay, then anomalous behavior, this is important. Nitrogen bond is weaker than single phosphorus bond. Why? Because high interelectronic repulsions of non-bonding. So on nitrogen you have these lone pairs. These lone pair repulsions will take place, which will make this bond weaker here, right, owing to small bond length, right? Then they form trihalides, except those of nitrogen. All trihalides of these elements except those of nitrogen are stable. All the trihalides except for nitrogen are stable. In case of nitrogen, only NF3 is known to be stable, and the properties of NF3 are very important, right? The bond angle, everything that we discussed in chemical bonding, right? That is very important. Okay. Then guys, we have group number 16 here. Group number 16. Yes, everybody, let's talk about group number 16 now. Group number 16, guys, is NS2NP4. Okay, so general oxidation state will be lower will be +4, higher will be 4 + 2 + 6. Electron gain enthalpy, there is no twist in radius and all, only twisted things are written here. Electron gain enthalpy is having different order here, and that is very important. Down the group, what should happen? Electron gain enthalpy should decrease, right? But here oxygen should have maximum, but it is on the least. Why? Because of the small size and lone pair. Oxygen has 2 lone pairs and it has a very small size, so it is not able to gain the electron. The tendency is not very high because of electron repulsions, and that is the reason it has least tendency here, right? Then electron affinity is also having the same order here, that is one on the same thing only. Ionization enthalpy lower than group 15 elements. If I talk about group 16, it is lower than group 15, because if I talk about group 15 elements, they are NP3, that means half filled. They don't want to lose or they don't want to gain. So you will have to give extra energy to take out electron from nitrogen, because it is P3, NP3, it is 2P3, right? So it is very highly stable. But it is not the case with group number 16. It is NP4, they will lose 1 electron, they will become NP3, which is highly stable. And that is the reason they easily lose the electrons, so their ionization enthalpy is lower. So -2 oxidation state stability is there, right? Because of the electron negativity here. Thermal stability, I'll talk about thermal stability here, wait a minute. Boiling point, firstly I'll talk about, increases from top to bottom, density increases up to arsenic, then decreases to bismuth, right? Now oxidation state -2 is decreases down the group because of decrease in electron activity. Tendency or stability of +4 oxidation state compares to this state increases down the group. Now this is the lower oxidation state. Lower oxidation state always increases down the group. The stability always increases down the group. Now let's talk about these things here. That is, wait a minute. Halides here, right? They have the same criteria. The halides, everything is important. The melting point, the boiling point, very, very important. Thermal stability, acidity, basicity, right? So thermal stability decreases down the group. Thermal stability is same as basic character. It is same as bond association enthalpy. And reducing character, or you can say acidity here, or you can say acidity, it is same, right? Boiling point, see, acidity, reducing character, that increases down the group. Basicity, thermal stability, bond association, enthalpy decreases down the group. Boiling point of this is going to be it should increase down the group, so it should be oxygen, sulfur, selenium, and then beryllium. But actually water has maximum boiling point due to hydrogen bonding here, due to hydrogen bonding. Similarly, same like ammonia, right? And you should also know the melting point here. You should also know the melting point here. Melting point is maximum in water. Then you have, I would write, it is same, melting and boiling point order is same in this case. This, after this you have selenium, then you have beryllium, then you have water. Here melting and boiling point is same. Melting and boiling point order is same in this case. Okay, done. Then you have all these elements form oxides of EO2. We are saying EO2 oxides they form. Ozone and sulfur are gases, while selenium dioxide is solid. Reducing properties of dioxide decreases from sulfur to beryllium. SO2 is reducing while this is oxidizing. It's a very important point that SO2 is reducing while beryllium is oxidizing in nature. Okay. Why? Because SO2 means sulfur 4 negative. This is beryllium. Wait a minute. This is negative. Now this will be 4 positive. This is beryllium 4 positive. Now we know that down the group lower oxidation state is more stable. So oxygen, sulfur, beryllium, then beryllium. Lower oxidation state is more stable in case of beryllium, right? As compared to sulfur. So sulfur is not that stable in +4 oxidation state. So it can already change, it can easily change its oxidation state. If it is behaving like a reducing agent, that means itself it is getting oxidized, so it can easily oxidize to this thing. It can easily increase the oxidation state because in sulfur higher oxidation state is more stable. That is why it can change its oxidation state to +6 easily, and that is the reason it is behaving like a very strong oxidizing agent. Okay. Then you have then you have both types of oxides are acidic in nature, right? Electron gain enthalpy, if we talk about why this has minimum, that I have already told you, this has minimum because of the small size and the electron repulsions here, right? Then ionization enthalpy, the elements of this group has lower as compared to this, that also we have discussed all of this. Okay, there is no need of discussing it again and again. Okay. Okay. Then you have reactivity towards halogens. Amongst hexahalide, hexafluorides are only stable halides. Sulfur hexafluoride, this is exceptionally stable for steric reason. Why? Because if you see SF6, what kind of, if you see it has half, it has 6 valence electrons plus 6, that is 6, that is sp3d2 hybridization. That means it forms this octahedral structure which is highly stable, right? So we say it is exceptionally stable here, right? Okay, done. Then you have all elements except oxygen form dichlorides, dibromide. These dihalides are sp3 hybridized, thus have tetrahedral structure. Well known monohalides are dimeric in nature. Monohalides, that is this element, and these are dimeric in state. That means SF does not exist, but S2F2 exists, S2Cl2, S2Br2, S2Cl2, Sc2. These dimeric halides undergo disproportionation as given below. That means they can easily get converted to tetra halide and simple metal here, right? Okay. Then the last one we have is for group number 17, right? Okay, these are the very, very important points of your P block. Okay, that's why I'm discussing that. In case of fluorine, all these things, what is the different thing that you will have? Atomic radii will remain the same. Ionization enthalpy will also remain like this. Fluorine, chlorine, bromine, iodine, it will also decrease. There is no difference that you will see here. The weird part will be in case of, wait a minute, let me just write it here. Yes, the most important part will be here, that is atomic radii is same, electron affinity. First point, in case of electron affinity, what you can say, or electron gain enthalpy, that is the same thing, right? You will have chlorine, then fluorine, then bromine, then iodine. Now fluorine is supposed to have maximum electron gain enthalpy, right? Fluorine is supposed to have maximum electron gain enthalpy. Wait a minute, why I can't see you guys here? Wait a minute, I can't see your chats. Yes, now I can see. Okay, so electron gain enthalpy is supposed to be maximum. It should be fluorine, then bromine, then iodine. But fluorine, because of its very small size and electron repulsion, because of 3 lone pairs, will jump to this second position. This is a very important exception here. Then you have bond dissociation enthalpy, again very, very important. Bond dissociation enthalpy is of the order chlorine, bromine, then fluorine, then iodine. So fluorine, again, because of its very small size, right, there will be so many electron repulsion, so FF bond will not be that strong. That is why it has very less bond dissociation enthalpy. This is again very important. Then guys, we have ionization enthalpy is same. This is also same. So these two are most important here. Then we talk about acidic strength or reducing power. That becomes this. That is iodine, then bromine, then chlorine. That means it increases down the group, right? And thermal stability, or this is also basic strength, or this is also bond dissociation enthalpy, that decreases down the group. That increases, here it increases down the group, increases down the group, increases down the group. This decreases down the group. Okay, this is how you will have this, right? This we have done. Non-metallic character, non-metallic character decreases down the group. Iodine show distinct metallic possess luster, and okay. Physical properties, one curious anomaly that we notice from smaller enthalpy of dissociation of this also we have discussed, yeah. Dissociation also we have discussed, this also we have discussed, right? Now this one, to they this for to understand this one, you'll have to go through like full thing here, that we don't need to do as of this lecture. They all react with hydrogen to give hydrogen halides, but affinity for hydrogen decreases from fluorine to iodine. They are saying, why I am not For how long I was not visible to you? Guys, I can see your chats is completely nonsense over here, right? That's for sure that I'm not gonna take your physical chemistry marathons or nothing here. But what the hell is this, right? What you want actually 10 days before your exams and you're doing this stupidity out here, right? Then don't say that, ma'am, we want to study or anything, right? Don't say all these things if you can't study. Don't tell teacher, ma'am, please take this class, ma'am, please take this class, and all that. If you're not that much dedicated to do that, right? Why to waste my time on that? Huh? Tell me. From 1 hour, I can see totally nonsense behavior in the chat box, right? You guys are not at all interested, right? It just irritates the hell out of me that what is actually happening, right? But still I'm like, okay, let's, there are some students who want to learn, let's teach for them. Then I can see you guys chatting in your regional languages, right? Just thinking that ma'am won't be able to understand anything. Haha, that's so funny. Should I start talking in Punjabi then? Then you will not be able to understand. If I am here teaching in a language, right, that you are able to understand, then you can also talk in a language that I am not able to understand. Is it that of a big deal? Isn't it? Hmm. So are you guys even interested, or should I just end the class now? Tell me. Should I? I'm not gonna talk about this later on. I just tell me yes, ma'am, no, ma'am, not interested. I'll just end the class now only. Right? Okay, tell me. I am here to support you only. Otherwise, I won't be teaching for 60 minutes with all that nonsense in the chat. Right? Now, beta, I know it was glitching. Okay, I can call the team in between the class, right? Okay. Chal. Now, this also we have done, right? Okay. Last part is this one, where you have melting point, boiling point, other things we have already discussed. Melting point, if you see, is going to be maximum for HI, right? Then you have HF, then you have HBr, then you have HCl, right? Boiling point here will be, boiling point here will be, I don't know, yeah, why it is glitching. Okay, HF, then you have HI, then you have HBr, then you have HCl. Okay, that is the sequence of melting point and boiling point here, right? Okay, so other things we have discussed. In the noble gases, there's just one thing, they have exceptionally high electron affinity. They cannot, that means they are not able to gain electrons only, they cannot gain the electrons, right? Okay. Huh. So exception of noble gases, electron gain enthalpy maximum in neon, then argon, krypton have same, then xenon, neon, and helium. Physical properties, lowest boiling point, any known substance, that is 4.2 Kelvin. It has unusual property of diffusing into most commonly used laboratory materials such as rubber, glass, and this. Now guys, it is the time for questions. Tell me, are you ready for the question part? अरे यार, oh god, that is, I have no idea why it is happening like that. I don't know why it was happening, huh? Sometimes the days are not good, I feel. Some days are not good, but chalo, we will not stop here. Now what to do if it is glitching, right? All we can do is we can study still, right? Okay, so let's see, right? First question here, everyone in the chat box, let's start with the first question over here, right? Okay, let's see. Now, first question, JEE 2026 is, consider the element nitrogen, phosphorus, oxygen, sulfur, chlorine, fluorine, the number of valence electrons present in the elements with most and least metallic character. Firstly, out of this nitrogen, phosphorus, right? Nitrogen, see, I'll just tell you here, this is nitrogen, this is phosphorus, this is fluorine, this is chlorine, nitrogen, oxygen, fluorine, 7, 8, 9. Yes. Oxygen, this is sulfur. Now they are asking you least and most metallic character here. Okay. Least and most metallic character. Okay. So what you have here, most metallic. So we know that along the period what is happening? Along the period metallic character is, non-metallic character is increasing, so metallic character is decreasing here, right? And down the group metallic character is increasing, right? So in that case, I say out of these three groups, this has maximum metallic character, and here also down the group metallic character is increasing. So this will be most metallic, right? And if I talk about least metallic here, in this case here metallic character decreasing, and here further it is increasing. So out of fluorine and chlorine, chlorine should have more metallic character. So that means this will have least metallic character. So now number of electrons they are asking here. In case of phosphorus, it belongs to group number 15. So 5 valence electrons. And here it belongs to group number 17. So 7 valence electrons. So answer will be C, that is 5 and 7 is the correct answer here. Correct? Okay? Clear? Next question is, in period 4 of periodic table, the elements with highest and lowest atomic radii respectively are. Right, everyone? Period 4, highest and lowest metallic radii you have to tell here. In period 4, highest and lowest metallic radii. Yes, everybody? Firstly, you should know what is period 4. Okay? Firstly, we should know what is period 4. So if you see this over here, right, this one is period 4. So 1, 2, 3, 4. In this case, they are talking about metallic radii, maximum and minimum. See, along the period, we know that the radius decreases. So this should have, but noble gases, van der Waal reactive, because of van der Waal, they have the maximum. So krypton should be maximum and bromine should be minimum. Because here it is decreasing and this should be minimum here. So krypton should be maximum and bromine should be the minimum here. Right? So we can write it over here. Right? Maximum is krypton. Right? Okay. This should be KR. Wait a minute. Period 4 they are talking about now. Period 4. Maximum is potassium or krypton. If I talk about this thing here, right, all of this, They are talking about maximum and minimum. Wait a minute. They are talking about elements with highest and lowest atomic radii respectively are. See, krypton is not given to me. Okay, so I'll take it as lowest one will be bromine, right? So all of this rubidium will not be the maximum here. That is not there only. So you have krypton. So you have potassium. So answer will be potassium and bromine will be the correct answer. That is C is the correct answer. These are very easy questions only. Correct order again 2026 question is correct order of C and no F in terms of second ionization potential. Second, now they are asking you the second ionization potential here. Yes, everyone, they are asking you the order of second. They are not asking about this is carbon, nitrogen, oxygen, fluorine. Second ionization potential. We know that ionization potential, the first if I talk about, how do you write this? Okay, even if you don't know anything about this, how do you write this? Okay, this will be ns2 np2, this will be, I'll write it as np2, this is np3, this is np4, this is np5. To take out one electron here, this will become np1, this will be very difficult, np2, this will be np3, this will be np4. Now to take out electron from here will be very difficult in case of most stable, that is oxygen. So oxygen should definitely have the maximum, so this is already ruled out. After that, it is very easy to take out electron from here. See, because after losing the electron, it will become np0. That is quite stable only because it is empty, right? So this will be having least. Least will be carbon is here. So this is also ruled out. In case of nitrogen and fluorine, right? In case of nitrogen and fluorine, where losing the electron is easy. So here also losing the electron is easy because it is getting converted to np3. So this also has low as compared to this one, right? Second ionization enthalpy they are talking about. Huh? This is first. After this, they will easily be able to, here if you lose the electron, this will become np1, right? So here answer should be B, right? Yes. Answer should be B accordingly, right? Okay. But let me just verify this with the data. I think in the data, second ionization enthalpy, oxygen, fluorine, no, it should be B only. Okay. It should be B. Because if we see this here, after losing, it is getting converted to very, very stable oxidation state, right? Okay. Tell me. What is the answer here, everybody? What is the correct answer here? Potassium, magnesium, aluminium, boron. If I say potassium, magnesium, aluminium, and then boron. If I say boron, aluminium is here, potassium, magnesium. Okay. The radii order they are asking. Okay. These are definitely non-metallic here, right? This potassium is here and this will be, this is in group number 1, right? This is in group number 2. So obviously along the period, the metallic radius, it is decreasing, right? In aluminium and boron, here it is increasing. Why? Because aluminium is down, right? So here it should, this is also correct. So this statement is true here. Atomic radius is always greater than ionic radius. That is not true. It depends upon whether you have cation or anion, right? So C statement will be the correct answer here. Next is the second ionization enthalpy of sodium is larger than the corresponding ionization enthalpy. The ionic radius of O2 negative is larger than that of F negative. Right? Tell me everyone, what about this statement here? Yes, everybody? Tell me. So they are saying that the second ionization enthalpy of sodium firstly you should draw here corresponding enthalpy of magnesium. This is sodium, this is magnesium, right? So in this case, what you have, in this case you have Ns2Np, Ns2Np1, this is Ns2Np2. You lose one electron, it will become Ns2, this will become Ns2Np1. You again lose one electron, it will become Np0. Here it will become Ns1, this will become Ns2. So definitely, which one is easy here? This one is difficult, this one is easy. So they are saying second ionization enthalpy of sodium is larger. That is correct, because here it is its stable form is stable Ns2 form is, we have to take out electron from a stable form. Here we have to take out electron to make a stable form. So this is easy, that is true. The ionic radii of O2 negative is larger than that of this. That is also true, because here this is having 2 electrons here that it has gained. Here this has gained only 1 electron. Moreover, oxygen has more size as compared to fluorine. So that is also true. So answer will be both the statements are correct here. Okay. Next question, everybody. X and Y you have to identify here. Everyone, X and Y you have to identify here. Let's talk about this. Elements X and Y belong to group number 50. They are saying element, there is two element X and Y, they belong to group number 50. The difference between electronegativity of X and phosphorus is higher. X and then you have phosphorus, X and then you have phosphorus is higher than the difference in the electron is higher than the difference between phosphorus and Y respectively. See, it is like nitrogen, phosphorus, na PSC. Okay. So if I see, we have seen the electronegativity order. This particular difference is higher than this difference, is higher than this difference here, right? So it was like you have to put it here. Firstly, if I put arsenic with phosphorus and bismuth with phosphorus, that is definitely not true. Here the difference is smaller as compared to that. So this is definitely bismuth, and if I say X is bismuth, this has a larger, then you have nitrogen and this, right? So in this case, down the group, what is happening? Electronegativity is decreasing here, right? So it should be X should have more electronegativity. So this is also not correct. In this case, nitrogen has more electronegativity, and we are saying that these two have higher electronegativity difference as compared to these two. So answer will be C is the correct answer here. Okay, done everyone. The correct trend in first ionization enthalpy of the element of third period of the periodic table. So third period periodic table, you can easily tell the first ionization enthalpy order trend. This so you can easily explain, guys, right? So in this case, third period, right? So that means fourth period, third period, that should be on your tips. So third period, if you see, they are talking about this thing. Sodium, magnesium, aluminium, silicon, okay, that is the third period here, right? So I have also told you about this, but now let's see if you're able to find this out or not, right? Let's see. Ionization enthalpy they are talking about, right? So we have done this, है ना? Group number 17. After that, it should be group number 17. Then it should be group number 16. If I talk about the ionization enthalpy here, right? Chlorine, and then you have phosphorus, right? Because 16, though it is sulfur, right? Then phosphorus, then you have group number this 16, then you have silicon here. Wait a minute, right? So you have how many groups? You have group number 14, you have group number 15. 14 is this one, 15 is this one, then you have 13 group also here, right? Then you have group number 16 also here, and then you have group number 17. So between these groups, you have to tell what is the correct order of ionization enthalpy here, right? So out of this, if I talk about the ionization enthalpy trend, to take out the electrons here, that will be group number 17, then you have group number 15, then group number 16, and here minimum ionization enthalpy trend will be least in group number 13. So answer will be aluminium and aluminium. This one is cancelled out. In this case, chlorine and this one is cancelled out, because after chlorine you should have phosphorus. So answer will be B is the correct answer here. Okay, so that's how you are going to tell the trend here, and this is a very important question that you must know. Okay, chlorine, then phosphorus, then you have sulfur, then silicon, then you have this one. Now in this case, what you will see, in this case, along the period, what should happen? Ionization enthalpy should decrease or increase. Size is increasing, ionization enthalpy should increase. So it should be like this, right? But in this case, you see a defect here. What is the defect? This is 13, this is 14, this is 16, this is 15, this is 17. You see a defect here. What is the reason for that defect? Why here more ionization enthalpy is required? Because of the reason that it is half filled. This is half filled stabilized. That is why what you will see a defect over here. This is 16 and here it will be 15. Rest of the things are same. Okay, understood? That's how you can answer this, right? Next is 2026 question again. CONF is the correct order in terms of first ionization enthalpy value. This is the correct order in terms of magnitude of electron gain enthalpy. Yes, everyone in the chat box, right? So if I talk about first ionization enthalpy, carbon, oxygen, same thing they are saying. This is same as this question. This question and this statement is same. Group number 17, then you have group number 15, then 16 and then 14. Why? Because of half filled stable configuration, it is very difficult. So this is statement is true. Then you have this one is correct order in terms of magnitude of electron gain enthalpy. That is also true because this has least because of its smaller size. So both the statements are true. That means B will become the correct answer here. Okay, understood everybody? Yes. Next question is the correct order in terms of atomic and radius. The correct order in terms of magnitude of electron gain enthalpy. So same kind of question it is there. It must be in different shifts here. So you can see a same pattern we can observe here, right? Okay. Everybody tell me in the chat box. Everyone. Okay. So first is we are saying, we are talking about the sizes here, right? So in this case, you have aluminium and magnesium. See, this is magnesium and this is aluminium, right? This is group number 2 and this is group number 13. So along the period, size decreases, right? So magnesium should have more size as compared to aluminium. Okay. Now, if I talk about cation and neutral, obviously neutral will have more size. Now either magnesium or aluminum, see this statement is false only, right? You don't even have to see further. And now if I talk about magnesium and aluminium, right, it is 2 electron, it is losing 3 electrons. So more is the charge, right? More is the positive charge, less will be the size here. So that is why this will be Mg2 positive and this will be aluminium 3 positive, right? So this statement is definitely false. The correct order in terms of magnitude of electron gain enthalpy, that is correct. Chlorine, bromine, electron gain enthalpy, oxygen has the least here. That is true. So this one is true here, right? So you can say statement 1 is false, statement 2 is true here, right? Next question is, which of the following represents correct trend in the mentioned property, right? Now here they have given 4 properties here and you have to tell the correct trend out of this. Okay, you can also use this by elimination method, right? Okay, tell me, yes everyone. Ma'am, can you say the deleted topics in P block and what to why you have to study the deleted topics? They have not asked anything from the deleted topics. They have not, these are all in your like these are all from your periodic table, that is in your syllabus, right? So why you have to study the deleted topics, tell me. Okay, chalo. So correct trend, I hope so you guys have answered it. Exception C, ma'am. See, what is the correct answer? What do you think? Which of the following represents correct order? So first ionization enthalpy, if I see, this is boron, then sulfur, then phosphorus, then fluorine. This is along the period. Ionization enthalpy increases along the period. That is correct. Okay. So that I can say is correct. Electron affinity here. Electron affinity, phosphorus, that is group 15, then sulfur. Wait a minute. This is phosphorus, this is sulfur, this is fluorine, and this is chlorine. Out of this, if I talk about the electron affinity is definitely maximum in chlorine, right? Because this is electron-electron repulsion, here this will have less. Here students, if you don't know the exception, then you can do mistakes here. Chlorine will have more as compared to this. So chlorine, after that you will have fluorine. And here if you see these two, electron affinity increases here. So these two will have like this. Wait a minute. Okay. Phosphorus, then sulfur, then either fluorine or chlorine, and out of this chlorine wins. So chlorine, fluorine, sulfur and phosphorus, that is also correct. A and B are correct. So this statement is not correct. Now if I have to see if C is correct or not, I can understand that what will be the answer. Metallic character, if you see, this is potassium, this is aluminium, this is magnesium, and this is boron. So metallic character is obviously more in potassium and magnesium. So aluminium will have less. So that definitely counts for wrong. And in this case, basic character, now we have the answer. C is not correct. Right now, D is correct or not, that I have to see. Okay. So in this case, if I have to see D is correct or not, in this case, you have potassium, sodium, this Lina, Yi, Ruby say friendship. So this is beta mange, sodium, magnesium, aluminium. Okay, and this is aluminium. Okay, it will be like this. So if I talk about the basic character, that has to be maximum in sodium and potassium because of group number 1. And out of this also down the group metallic character increases, so potassium will have more. Potassium, then sodium, then magnesium, then aluminium. This is absolutely correct. So answer will be A, B, D is the correct answer. Okay, understood? A, B, D, that is B will account for the correct answer here. Right? So they have asked you 4 properties in this one question here. Next question is, guys, it is related to the chemical reaction here that they asked in 2026. Okay. The unexpected question right? The unexpected question that they have asked here. Wait a minute, guys. I just got a call. Just give me a second. Okay. I'm so sorry. I just got some call in between. Yes. So this is a question that was quite unexpected, right? So that is Na2B2O7, right? Now this gives you two compounds here, and what are those two compounds? So when you heat it, it gets converted to NaBO2, and this will be B2O3. Okay, these are the two compounds that it gets converted to, right? What happened? Ma'am, I am here only. Yes. Now see, you have, when you heat this Na2B4O7, you get NaBO2 and B2O3. This was actually a tough question of your JEE attempt 1, right? So when you heat it, when you react this Y, that is this B2O3 with CuSO4. Wait a minute. This should be 2 of this now. So 2 of this will be this thing. Wait a minute. NaBO2, NaBO2, if I say N and Y are possible, in this case, if I say Y reaction, now the question is which one will be Y and which one will be what? If I say, if I take here 2, right, and then this will become 4, this will become 6 and 7, 8, right? If I say here you have 2, then this will become 2Na and 4B, and oxygen will be 4, 5, 6, 7. Only in this case it is becoming like this. So that means CuSO4 further reacts with B2O3. Okay, so that means this one is B2O3. Y is B2O3. Okay, B2O3 reacts with CuSO4. It gives you SO3 and it gives you CuBO2 twice. Okay. Then after this, if I say there is some Z that also, okay, that is Z and that is X. Now they are saying Z means CuBO2 twice, that reacts with NaBO2. With carbon, it gives you Q and some Na2B2. That means this is again, it is giving in carbon monoxide is being formed. So when you react this with NaBO2, it forms CuBO2. Okay, this is as it is reaction, you have to remember. Now they are saying that oxidation state of Z and Q. Z is what? Z is CuBO2 twice, that is Z, and Q is CuBO2. Now you have to find the oxidation state. Now this one though you can do yourself as well. Tell me guys, can you do this yourself? This one though you can do yourself as well. Na? There is no big deal in that. You have BO2, this will be +2 and this will be +1 here, right? So answer will be here, it will be +2, here it will be +1 oxidation state. So answer is going to be A is the correct answer here. Yes. Okay, so that was a very different question of JEE attempt 1. Very different and very difficult, I would say, difficult question of attempt 1. Unexpected question of attempt 1. Right? Next question is, now here you have to know all these reactions only then you will be able to solve, and I think very rare students must have solved this. Right? Okay? So you have to like remember this only, but at this point still, because it was also there in 2026, but I will still advise students not to undergo reactions that much. You will see one question they have asked based on reactions. Most of the questions are related to trends and exceptions, right? So you have to pick out that thing which has more maximum advantage for you, that has maximum chances that will be in your exam. So it has very less chances. It was there. If you're like, ma'am, I don't want to take any risk, go through all these reactions, right, of boron compounds. This is all there in boron compounds, right? So if you're like, okay, I'm fine with taking that risk, because that risk you can take, right? But yes, I am not saying these kind of question you will not find in the exam, right? You can see one sample they have given, right? So that is in one shift they have given this question, right? But in most of the shifts they have asked questions from trends only, right? Okay, so now it's your choice. If you are like, okay, I know the trends completely, I can go through this as well, you go through that. If you're like, okay, I don't understand the trends and all also, then why you're going through this? First you understand the trends and exceptions, then this is the last thing that you should do, right? Now next question is again JEE Mains 2026 question, right? Okay, yes. Again guys, next question here, that is statement 1 is the increasing order of boiling point of hydrogen halides is HCl, HBr, HI and HF. Okay, boiling point of halides, we have discussed this majorly. That was HCl, then HBr, then HI, then HF. That is true. Increasing order of melting point of halides is HCl, HBr. Then here was the twist. This was a different, okay. Here it was HF was maximum, but here HI was maximum. That is also true. So we can say both the statements are true. Okay, melting boiling points I have taught you there, right? Then next question is based on hydrides, and this is a statement based question, right everyone? This is a statement based question. My aim is to go IIT. Ma'am, just ask me, will this come in JEE? Yes, this will, beta. If you're like, if you have a dream of going into IIT, then you should definitely do reactions as well. But again, I am saying that totally depends upon which situation you are at right now. If you're like, I don't remember any exception, I can't solve exceptions or trend question as well, then why you are worrying about reactions, right? That is very less probability, but it has probability. But if you're like, okay, I know full in detail, but I want to do something extra as well, then you go through reactions and structures also, right? Okay, yes everyone. So let's see. You have to tell correct or incorrect. You have to tell the correct statements here. The stability of hydrides decreases down the group. That is correct. Stability decreases. Basicity also is same as stability. That also decreases. Reducing character is opposite to basicity. That it increases. That is also correct. Boiling point is increases down the group for hydrides of Nitrogen, no, it does not have a simple rule. Nitrogen has an exception, right? So that is why this is not correct. So answer will be A, B, C is the correct statement here, right? Okay. D is not the correct statement. Boiling point does not have a simple trend. Because of the hydrogen bonding of ammonia, the trend shifts here, right? So that is why answer D will be the incorrect, right? Next question is, they are saying X is an oxoanion of lightest element of group 7. The metal in +6 oxidation state is in X. The color of potassium salt of X is what? Okay, so let's talk about that. Oxoanion of group 7. Yes. Oxoanion. X is an oxoanion of the lightest element of group 7 in the periodic table. The metal is in +6 oxidation state in X. The color of the potassium salt of X is what? C. If you see, this can be from, this is actually not from P block, this is actually from D block. From group number 7, now you have manganese, and the salt of manganese oxo salt is this one, where X is -8 is equals to -2, where X is in +6 oxidation state. And now they are saying the color of potassium salt, KMNO4. KMNO4 is purple in color, so you can say why it is green then. KMNO4. Acha, K2, oh, KMNO4, it will not form KMNO4, wait a minute. K positive, it will shift the oxidation state. K in front, here it will be 2 because cross multiplication will be there, MnO4, and here it is 1, so it will be 1. Yes, so it will be green in color. Yes. Okay, so answer will be D, that is green in color, right? Next question, guys. Next question. Choose the incorrect statement here. Carbon exhibits negative oxidation state along with +4. Carbon cannot exceed covalency. Among the isotopes, this is radioactive. CO2 is most acidic oxide among dioxides of group number 14 elements here. Yes, everyone? Choose the incorrect statement here. Tell me, carbon exhibits negative oxidation state along with this. Yes, it do exhibit negative oxidation state. Carbon cannot exceed its covalency like more than 4. That is also correct. Pentavalent carbon does not exist. Among isotopes, this is radioactive. That is not correct. CO2 is most acidic. Yes, it is the most acidic oxide among dioxides. Then CO2, then down the group basicity will increase, acidity will decrease here. So answer will be C is the incorrect statement here. Next is, it is noticed that B2 positive is more stable than B4 positive. SN2 positive is less stable than this. This is purely based on the oxidation states, and this they have related it to thermodynamics, but you can answer that. They have related it little to thermodynamics. Okay? Yes. Tell me. It is noticed that Pb2 positive is more stable than Pb4 positive. Okay. So firstly, you should know that Pb2 positive I am talking about, then this is more stable than Pb4 positive. Yes. But tin2 positive is less stable than this. This also we know, down the group lower oxidation state stability is more. Now they are saying here it is in +4 oxidation state, this is in +2 oxidation state. So Pb2 positive is more stable than Pb4 positive. So definitely this is a spontaneous process. This process can happen. That means delta G of 1 has to be negative here. So delta G of 1 should be less than 0. That is correct. Okay. Delta G of 1 should be greater, no. Delta G of 1 should be less than 0, that is correct. Delta G of 1 should be greater, that is not correct. Delta G of 1 is correct, less than 0, that is correct. Okay. So this delta G has to be less than 0, that is correct. In this case, you have tin 4 positive and you are converting it into 2 positive. 4 positive is a very stable state. It cannot be converted into 2 positive. So this is a non-spontaneous process. This will be greater than 0. Here delta G of 2 is also, they are saying delta G of 2 is also less than 0. That is not correct. Here delta G of 2 is greater than 0. Delta G of 1 is less than 0. That is correct. So answer will be B is the correct answer here. Okay. So it was a very simple question. It was not at all a query question. Okay. Correct statements of the following. Now they are asking you the correct statements here, everybody. See, JEE 2026 questions are so many that in that only we so much time we are devoting. Correct statements. Ionic radii of trivalent cations of group number 13 decreases down the group. Like you have B, then you have aluminium. Ionic radii, they are saying it decreases. See, cation is same, charge is same, down the group size will increase. They are saying it is decreasing, so that is not correct. Okay. Electron negativity of group 13 decreases down the group. Electron negativity C of group 13 element, if I say size is increasing, group number 13 element, it purely does not decrease. We have seen it in group 13 exception, that a shift that we can also see in the group number 13, so that is also not true. Among the group 13, boron has highest first ionization, that is correct. That is why it is not able to form it is not able to form ionic bonds. First three ionization enthalpies are very high. Trichloride and triiodide group 13 elements are covalent. Trichloride and iodide are covalent. That is also correct. Okay, right? So we can say C and D are the correct statements here. So answer will be B is the correct statement here, right? Next is JEE 2026 again, statement 1 and statement 2 is given to you. This is regarding boron reaction part as well. This is also regarding X and Y. Okay. This is same as that we have discussed, isn't it? This is quite same. This one part they have also given in some other shift. We have discussed that question. You can solve it. Tell me. Tell me, everybody. So they are saying X and Y are most and least electronegative elements respectively among these. So most electronegative is definitely nitrogen. Nitrogen is most electronegative, so it will be X is nothing but X2O3 is nothing but it is N2O3, and that is acidic in nature, right? Yes. And if I talk about least, which is also amphoteric in nature, that will be antimony, so it will be Pb2O3, that is your Y. Okay. So this statement we can say is correct here, right? So most is nitrogen, least is antimony, and nitrogen has acidic and antimony has amphoteric. Next question is BCl3 is covalent in nature and gets hydrolyzed in water. It produces this and this in aqueous medium. Yes, everybody, tell me. Tell me, everyone. Tell me, everyone. So you have BCl3 that is covalent in nature. When it is hydrolyzed, it produces B2O3. B2O3, na? Yes. Sorry, B2O3, I am saying BOH thrice. Boric acid it will give. Okay. Boric acid. This one is not boric acid. Okay. So these two things it will not give. It will, along with this, it will give HCl to you. So this statement will become false. So that means statement 1 is correct, statement 2 is incorrect here. Next is the halogen that makes longest bond with hydrogen in HX has smallest covalent radius. Achha, this also you can tell. Tell me what out of these two, what is the statement? बिल्कुल सही बेटा. In detail तो what I can do, this is question practice, right? Tell me. Halogen that makes longest bond with hydrogen has the smallest covalent radius. It is making longest bond, then why will it have smallest this? This is the statement, anybody can tell that this is false. Group 15 element hydride has lowest boiling point among corresponding hydrides of other elements of group number 15. The maximum covalency. See, firstly you have to tell what is that, wait a minute, the group number that has lowest boiling point. Lowest boiling point will be phosphorus, right? And phosphorus has covalency of 5. So that means this is also false. So you can say both the statements are false here, right? Next is p block element. Now this is a big question here. Let's see. This is a big question, everybody. Let's see that. So if you see group number 16, group number 16, I am saying p block element E and hydrogen form a binary cation, okay? Okay. While EH3 on treatment with K2HgI4 in alkaline medium give precipitate of basic mercury to amido iodide. Given below are first ionization enthalpy values for first element from group 13, 14 this. Identify the correct first enthalpy value of E. First you have to identify what is the group that we are talking about. Okay? Yes, everybody? Let's talk about the group. So they are saying, let's see the hint that they have given here. The elements and hydrogen is binary cation is this. They are saying it forms a p block element E and this forms a binary cation this. While EH3 on treatment with K2HgI4 in alkaline medium gives precipitate of amido. See, from this amido, I can see they are talking about nitrogen. Okay, so very small hint is given to you, but if you identify, you can see the hint. See, amido means nitrogen has to be there. That means this p block element is nothing but nitrogen they are talking about. That means this binary cation is nothing but NH2 or you can say NH4 positive. Okay, and this is NH3. Okay, first ionization enthalpy values of each element. Identify the correct first ionization enthalpy of group number 50. Okay, so ionization enthalpy is going to be maximum, like if you see group number 13, 14, 15, 16, 15 will be maximum, then 16, then 14, then 13. So it has to be maximum here. And maximum I can see 1402, so that will be the maximum. Okay, so it was not a difficult question as such. This is maximum. You don't even need to know like full reactions and all, right? You just need to see this amido, that is a hint, that means it is nitrogen. That means they are talking about nitrogen here. Now they are saying identify the enthalpy of nitrogen. Out of these four, 15 has maximum enthalpy, so answer will be which one is maximum. This A is maximum. Okay, understood? It is Nestler's test. Very good. Even if you don't know Nestler's test, even then you can answer. If you know, that is great. Okay, so if you know, that is great. Even if you don't know, from this hint you can identify. Okay, understood? Yes. Then guys, next question again, this is a question of reactions, right? So you have to tell the answer here. Yes, everybody, that was also a very, unexpected question in the exam, right? A very unexpected question in the exam. So they are asking you ABX, right? PbCl2, K2Cr2O4. That is, you are reacting it with chromate. And it is going to give you, firstly, what is A? Right? A will see, even if I don't know the reactions, I'll tell you how I will answer this. See, A definitely will not have sodium here. So it is sodium here, sodium here. This can be A. Pb, because this is Pb, this is plus 2, and this will be CrO4, this is minus 2. So they will combine, this will form PbCr2CrO4. So A is going to be PbCrO4. After that, it reacts with sodium, right, NaOH. Then it is going to form a compound, Na2CrO4 will be reacted here, and OH will react with this further, that is this one. So it will react like this, NaOH will react with PbCrO4, Na2PbOH4, that it will give you. Furthermore, it is same only, so you don't have to worry about it, but still you should know, okay? This one it will do. After that, BaSO4, they are saying that it reacts with CH3COONH4. It gives you NH4 twice SO4 and this one. So now, how do we identify this? See, this one is NH4, this is negative, this is positive, this is plus 2, this is minus 2. Okay. So NH4 and this reacted to give NH4 twice SO4. Then you have CH3CONA, that should definitely be there. Here you don't have CH3CO4N. CH3COO negative should be there. If you don't have here, then where it has gone? So this cannot be the answer, this will be the answer. Okay, that way also you can answer this. Okay, by elimination also you can answer this question here, right? Okay, next question guys, a number of pairs are given to you and they are saying that which contain oxides that are both amphoteric is 2, both that are both are amphoteric. Then they are talking about BF3 here. Tell me, both, now based on the oxides they are asking the questions like the nature of oxides, right? Tell me, which of the following are amphoteric in nature? Yes. Tell me guys. Carbon and silicon. Carbon is acidic, silicon is also acidic in nature. So this is not amphoteric, both are acidic in nature, right? Tin oxide or dioxide, both are amphoteric in nature. This is correct. Lead is also, both are amphoteric in nature. That is also correct. Germanium, both oxides are also acidic in nature. So I can say this statement is true. Two pairs are both amphoteric in nature. BF3's electron deficient molecule act as Lewis acid, forms a duct with NH3, has trigonal planar geometry. Everything is correct regarding BF3. So we can say both the statements are correct here. So answer will be C is the correct answer there. Okay everyone, tell me. Is that clear? Is that clear everyone? Tell me. You can tell me what are the other exams that you are preparing for. I can take classes for that. Okay. See. Now what you have DNF block. Okay. So DNF block, tell me, do you want me to revise DNF block with you or you want me to directly jump to the questions part? If you want, I can directly jump to the question part and do a quick revision as well. Tell me, what do you want me to do? Yes, everyone. VIT okay. No worries, I'll take mock test on that as well. Tell me. Now, shall we move here? If I talk about this thing here, Electronic configuration, yes. NEET exam to is bit same as JEE only, right? So what I am teaching you here, you revise that. Revise firstly, tell me, do you want me to revise or firstly directly jump to that? Do you want me to revise? Chalo, let's revise then. Okay? Yeah, you can just put down the exams that you're preparing for in the comment section. I'll definitely see that. Okay? Yes. BitSat. Okay. Cool, cool. Cool. Chalo. Now, general electronic configuration is n minus 1, d 1 to 10, ns2, 0, 1 and 2 electrons can be there. These are the 4 periods that you have. If I talk about the electronic configuration, that is exceptional in case of chromium and copper, right? Because of half filled and fully filled electrons, this is the exceptional electronic configuration that you will see. In this case, what you will see here, here you have exception molybdenum, tungsten, you have, sorry, technetium, you have this one, this one, this one, and very important is platinum. It is the only element which has 0 electrons in s orbital in the entire transition state series, right? Others, they have same. After that, platinum, and this is AU. They both have 1 electrons here, right? Then in this case, you have only this one which has 1 electron here. So I have just listed down all the exceptional, okay? Now next is, if I talk about this table, from this table they can ask you one question that zinc, cadmium, mercury, where one manganese, they don't have specific structure, because here they have written cross, or you can say XXXX in all these cases, they don't have specific structure, okay? So they can ask you this. Zinc, cadmium, mercury and manganese. And zinc, cadmium, mercury are non-transition elements. Why? Because they have fully filled orbital in excited as well as ground state, right? Then this is the chart. From this chart, I have concluded some important, very, very important trends for you, right? Now guys, here now you have to revise it yourself. I can only give you the notes, I'll provide you the notes, right? There is nothing to teach here, right? So this is all the exceptional trends. Reason is again the same thing: inert pair effect, poor shielding effect, same reasons, right? So these are the important exceptional trends, right? Enthalpy of atomization, they ask you first IE, they ask you second IE, they ask you density. So all these 4 trends are difficult, but you have to learn these 4 trends, okay? As it is, you should learn this. Then in this, what they ask you, in this they ask you that maximum melting point among 3D, 4D and 5D is chromium, then molybdenum and then tungsten. They have the maximum boiling point, right? Okay. Crash course for which exam will start. Okay, okay, I'll let you know about it. Okay, I'll let you know. Now please focus here, right? Then they can ask you that unexpectedly technetium and manganese, they have drop. In technetium and manganese, you have a sudden drop that is very unexpected, because they have 5 unpaired electrons, so they should have high melting point, but unexpectedly they have low melting point. So there is a sudden drop that you will see. Then here, trends in atomic radii of 3D elements. In atomic radii of 3D elements, this trend they ask you, right? Directly based on this trend also they ask you the question that firstly it decreases, then it remains constant, then suddenly it starts increases. This is the atomic radii. In the oxidation states, what you have in the oxidation state, what you will see here, in this case, from scandium till manganese, maximum oxidation state is the most stable. That means highest oxidation state is the most stable. But after manganese, what you will see, lower oxidation state will start becoming stable here. Lower oxidation states will start becoming stable. But from scandium till manganese, higher oxidation states are more stable. And if you see the group is 3, group is 4, group is 5, group is 6, group is 7. So till scandium, till manganese, the group number and the highest oxidation state will coincide with each other. Okay, right? Yes. Now, in this case, what they ask you, 2-3 questions, 2-3 lines I am giving you that they ask you. The stability of half-filled d orbital in manganese and the completely filled d configuration of this are related to their E0 value. So just simply remember this one thing. If you are getting converted to a more stable oxidation state, for example, from 0 to +2, it is getting converted to a stable oxidation state, right? That means here 0 to +2 is oxidation, increase in oxidation number. If here this is stable, that means this reduction potential will be very low, will be negative. It's a simple fact. See, if I am saying this is 0 oxidation state, this is +2. Overall, here oxidation number is increasing. Oxidation number is increasing here. That means this defines oxidation. If I say this is a stable, after losing 2 electron, it is getting converted to a stable form. That means oxidation potential is very high. That means reduction potential will be very low. Okay? That means oxidation potential is very high and reduction potential will be very low, right? So all these things are written here. Now they are saying that the stability of half-filled D in manganese +2 oxidation state means D5. So manganese to manganese 2 positive, you are getting converted to a very stable oxidation state, that is D5. That is why oxidation potential is very high, and that is why its reduction potential will be very low. Okay, the completely filled d orbital, this is also a very stable oxidation state, D10. So again, its reduction potential will be low because its oxidation potential is high. Whereas nickel is related to highest negative delta H hydration. They are saying that in the case of nickel, so if you see this here, manganese, then you have zinc. Zinc is this, manganese is this, then you have nickel, right? Here the reduction potential values are quite negative. Why they are negative? Because of this reason. Okay. Then again the same thing. So just I'm telling you, if you have M2 positive, 2M3 positive, right? That means oxidation number is increasing. So if I say this is unstable and this is stable, that means oxidation potential is positive. That means reduction potential will be negative. Okay, got it, right? All of these things are mentioned here, right? I'll just provide you the notes. You can just go through all the lines here. I'm giving you important words here. So if you see this, copper 2 positive with iodine, it forms Cu2I2, right? However, Cu positive disproportionates to Cu2 positive and Cu. That is very weird thing because this is 3D9 and this is D10. According to us, this should be highly stable. It should not get converted to D9 configuration, but it does, right? The stability of Cu2 positive rather than Cu is due to much more negative delta H hydration of Cu2 positive than this. Because of that reason, because delta H hydration is more produced in this case, so it becomes more stable, which is very unexpected because here it is D9 configuration. But in aqueous medium, this is more stable because it has negative value of delta H hydration. Okay. Then here they ask you one question, that in manganese, in case of fluorides, manganese is only forming +4 oxidation state with fluorine. But in case of oxygen, it is forming +7 oxidation state. Why? Because of multiple bonds. Because here it exists in multiple bonds with oxygen. That is the reason. Okay. Then unpaired electron under root n+2, that I have already told you in coordination chemistry as well. In this case, they ask you Which one is colorless? If something has D0, right, that will be colorless. And they ask you the firstly, so they ask you unpaired electron that you define from here. After 6, this is 1, this is 0, 1, 2, 3, 4. This is 5. But in 6, you say 10 minus 6 is 4. This is 10 minus 7 is 3. This is 10 minus 8 is 2. This is 10 minus 9 is 1. This is 10 minus 10 is 0. That's how you tell unpaired electron. 1, 1.7, 2, 2.8, 3, 3.8, 4, 4.9, 5, 5.9. Directly you answer it this way. Okay? Then let's talk about this question here. Right? Before going through this question, I also want to tell you, because the sequence is there. So if you want to see the color of the compound, this is also very important. They ask you the color of the compound in JEE. So that is why in this case I have written, this is like I have combined on the colors and the ions in just one page. These are colorless. This is purple. These are blue colored. These are green colored. These are violet colored. This is pink color. This is yellow color, and this is bluish pink color. Okay. This is according to your NCERT data I have given, and in your NTA relies on NCERT data more than anything else. Okay. Now, shall we do the questions? Tell me. I think, wait a minute. Chalo, let's do 2 questions. Wait a minute. First, we will do 2 questions, and after that, some part of DNF block will do. Then after that, more questions will be there. Okay, tell me. Yes. Shall we do that, everyone? So, I'll not solve it like throughout. I'll just give you where the questions are tough. There I'll teach you properly. Pair of transition metal ions having same number of unpaired electrons. Same number of unpaired electron. Right? So if you see this here, right, I'll just give you the directly answer. Answer is this. I'll tell you how it has the same number. Vanadium is nothing but 4s2 3d2. Okay. Vanadium 2 positive is nothing but 3d2, so 2 unpaired electrons. Cobalt is nothing but it is 4s2 3d7. So cobalt 2 positive is 3d7. T verb. Acha, T verb. This is 3d3, huh? This is 3 unpaired electron. And this is 3d7, that means 10 minus 7, that is 3 unpaired electrons. So these two have the same number of unpaired electron. I am just giving you directly the answer. You have to solve this one, this one, this one, and then go to this one. Okay, that's how you will tell the unpaired electron here whether they are same or not. Okay, then a question that was asked in JEE 2025, that was first transition element metal, that is 3D, which has highest enthalpy of atomization. Now in this case they ask you the highest enthalpy of atomization. That was there in vanadium. Vanadium in its equated ion exists in green color. Vanadium 3 positive is of green color. Okay, so the nature of oxides is what? The nature of this oxide is going to be basic. This is based on the nature of oxide. Okay. Acha, one thing I forgot to take here, that was the table of nature of oxides. Like which of the following is amphoteric, acidic, basic, all the oxides in just one go. So I'll send you that table on your JEE Telegram channel. Okay. Next is, this is again cramming part. These are the catalysts and these are the uses of those catalysts that you have. This is again directly from your NCERT and from your PYQs. Okay. Now next, let's understand the topic of lanthanoid contraction that I already told you in the starting of the class, that because of 4f, poor shielding effect of 4f orbitals, what will happen? They will have decrease in their size, so lanthanoid contraction will take place. Okay. So lanthanoid contraction is abnormal decrease in ionic and this radii due to 4f, poor shielding effect of 4f orbitals. Right. Now, in the case, the cause of lanthanoid contraction is poor shielding effect of 4f orbitals. Right. Due to this decrease, the atomic radii, the ionization enthalpy as well as electron activity increases. because atomic radii is inversely proportional to atomic radius. They are hard to separate due to this, and also the radii of 4D and 5D series becomes approximately same. That is also one of the consequence of lanthanoid contraction, right? Okay. Then guys, from this table they ask you questions from electronic configuration, so I'll just write it here. See, firstly 4F0 is there here, here, and yes, these two. So you can say 4F0 is in which case? F0 is in the case of cerium 4 positive, this is cerium 4 positive, and lanthanum 3 positive. And lanthanum 3 positive, they have 4F0. In case of half filled, you have this one, you have this one, and you have this one. This is for europium 2 positive, terbium 4 positive, and gadolinium 3 positive. And this is also for gadolinium 3 positive. Okay. Completely filled is for this one and this one. That is ytterbium 2 positive and lutetium 3 positive. Ytterbium 2 positive and lutetium 3 positive. So these are the things that have 4F0, 4F7 and 4F14. Now here one more question that they ask you, that cerium plus 4, it easily gets converted to plus 3 oxidation state, because in lanthanide most stable oxidation state is plus 3. So oxidation number decreases, that means it easily can be reduced. That means it's a very good oxidizing agent. So this is what they ask you. Cerium 4 positive is a very good oxidizing agent. Similarly, europium can easily be converted to europium 3 positive. So its oxidation number can increase easily. It can easily undergo oxidation. So it is a very good reducing agent. It's a very good reducing agent. Okay, that is a very good reducing agent, right? Then guys, this is about the reaction part, so I'll just quickly go through that. First thing is the preparation of potassium permanganate. If you see, this is pyrolusite ore that reacts in basic medium to form potassium manganate. Potassium manganate, which is green in color, that in the acidic mediums get converted to permanganate, that is purple in color. Now conversion of potassium manganate to permanganate can also be done by electrolytic oxidation, right? Another method by lab preparation is Mn2 positive reacts with peroxodisulfate to directly give permanganate. This is in lab preparation, we directly do this. Then if you talk about manganate and permanganate ion, this is green color and this is paramagnetic in nature. I'll tell you why. In manganate ion, this exists in Mn6 positive oxidation state. That means it exists in D1. In permanganate ion, it exists in Mn plus 7, that is D0. That is why D0 means no unpaired electron, so it is dimagnetic, and manganate ion is paramagnetic in nature, and both are having tetrahedral shapes, right? It forms dark color, the color is dark color. Now when you heat permanganate ion, it gives you manganate, MnO2 and O2. This is very, very important. This is a very important decomposing reaction in heat, thermal decomposition, right? And it is isostructural with KClO4. That means this also exists as tetrahedral, right? Okay. Now let's do some questions here. MnO2 decomposes on heating to which thing? It decomposes to, wait a minute. It decomposes to form O2 along with what? O2 along with MnO4 decomposes, why they have given two things here? K2MnO4, no? Yes. K2MnO4 and MnO2. So this will be the correct answer here, that we have seen that when it is decomposed, K2MnO4, MnO2 and O2 is formed. That means C will be the correct answer here, right? Then they say, why do we use concentrated H2SO4 and not concentrated HCl in KMNO4 titrations? Why? Because concentrated, if you use concentrated H2SO4, KMNO4 is converted to Mn2O7. That is also very important. I'll tell you about this as well, right? KMNO4 with concentrated HCl is converted to manganese chloride, not to manganese oxide. That is why we use concentrated H2SO4, not concentrated HCl here, right? Then we talk about the properties of potassium permanganate, that in acidic medium it is converted to Mn2 positive. It converts I negative to I2, not iodate, to I2. It converts Fe2 positive to Fe3 positive. That means it acts as an oxidizing agent, right? It converts oxalate to carbon dioxide, sulfide to sulfur. It converts SO3 negative to SO4 negative. It converts NO2 negative to NO3 negative here. Okay. Then in the alkaline medium, MnO4 permanganate is getting converted to MnO4 negative, and in the neutral medium this is getting converted to MnO2. This is very important. Okay. Then if you talk about its reaction in neutral or faintly alkaline medium, I negative is converted to iodate ion, not I2. That is very important. Rest of the things are same. SO2O3 2 negative to SO4. Then this is also very important, that permanganate ion, when it reacts with Mn2 positive, it forms MnO2 and 4H positive. That means permanganate ion with Mn2 positive is getting converted to manganese dioxide. Okay, some other reactions. I told you about Mn2O7 that is formed when permanganate ion reacts with H2SO4. Now this is the structure of Mn2O7, and this Mn2O7, when it decomposes, it gives you MnO2 and O2. This is the thing that this I should in fact write it here, right? This I am writing here only. You have KMNO4 reacts with concentrated this, it gives you Mn2O7. This Mn2O7, right, it has this structure where it has one Mn bond, 6 Mn double bond O bond, right? And in this case, it decomposes to MnO2 and O2 here, right? Okay, so I'm giving you extra reactions as well for that, right? Then it also converts peroxide to oxygen. It also converts arsenic O3 3 negative to arsenic O4 3 negative, right? Okay. Then let's do some reactions of total charge of, let's do 2023 question on this. Yes, everybody, tell me. Ready for this? Ready? Now they are saying total charge in the oxidation state of manganese involved in the reaction in the acidic medium is what? So if I see MnO4 negative with I negative, it gets converted to Mn2 positive. Mn2 positive, yes. Okay, then this is getting converted to I2. Just know this thing. If I see this is plus 7 oxidation state and this is plus 2, so the total charge involved is 5 electrons here. So I can see 5 Faraday charges involved here, right? 5 Faraday charges involved here. 5 Faraday, that means 5 electrons are involved here, right? Next question is, we are saying that MnO2 reacts with KOH with oxygen. It gives you which of the following things? Yes, everybody? MnO2 pyrolusite ore, it reacts in basic medium. It gives you permanganate, that is K2MnO4, right? Product A is neutral, acidic, when disproportionate into B and C. They are saying K2MnO4, it disproportionates into which thing? B and C. That is KMnO4 and MnO2. Okay. The sum of spin only magnetic moment of B and C is what? Here number of electrons, Mn exists in +7 state. Okay. Here Mn exists in +4 state. Here it will have mu is 0 because number of unpaired electron is 0. In +4, 4 is 2, 3d, 5 means 2, 3, 4. It is number of unpaired electron is 3 because it will be 3d, 3. So mu is going to be 3.9. So total magnetic moment is going to be, mu total is going to be 0 plus 3.9, that is nothing but approximately 4. So answer will be 4 Bohr magneton. Okay. Next is potassium dichromate, guys. In potassium dichromate, what you have, the fusion of, this is chromite ore. Chromite ore, it reacts with Na2CO3 and oxygen to give you Na2CrO4, that is yellow solution, that is sodium chromate. Okay. Then the sodium chromate in acidic medium is converted to sodium dichromate. The sodium dichromate further reacts with KCl to give potassium dichromate, that is of orange color. Okay. Now they are saying the properties. This is a very, very important point, that chromate ion that always exists in basic medium, and dichromate ion that will always exist in acidic medium because they are pH sensitive. So this will always exist in acidic medium, this will always exist in basic medium. This is also tetrahedral, this is also two tetrahedrons are connected with each other. This is CrO4 2 negative and this is Cr2O7 2 negative. Right, that is the difference. Okay. Now they are saying the oxidation state of chromium in chromate and dichromate is same. See, if you see, this is chromate and this is dichromate. Dichromate exists in, chromate. This is again pH sensitive, same question only. That dichromate exists in only acidic medium. If you give it basic medium, it will be converted to chromate. Chromate, if you give it acidic medium, it will be converted to dichromate. So I have written it in a very simpler way that dichromate exists in acidic medium, right? Then why N2Cr2O7 is used here, is not used in redox titrations as primary standard, but this is used. Why? Because KSP, this is more soluble, that is why it is not used. This is less soluble, that is why it is used in the redox titrations, right? Then if you heat K2Cr2O7, it will give you potassium chromate, CrO3 and oxygen. This is also a very important reaction. Okay. Then guys, you have how it behaves. See, we know that dichromate only exists in acidic medium, that it converts into Cr3 positive in acidic medium, that is of green color, right? It converts I negative to I2, sulfide to sulfur, Sn2 positive to this, means it oxidizes things, right? Simple way, it just oxidizes things, right? These are all the oxidations that it does. Then very important that dichromate, when it reacts with Cl negative, it gives you chromyl chloride, that is deep red color vapors. And this chromyl chloride, when it is reacted in base, it gives you CrO4. That means in basic medium, it gives you chromate. Dichromate reacts with Cl to give chromyl chloride, which on basic medium gives you chromate. Okay. That again, these are not in your NCRTs, but they are important. Now we say that it is used in chromyl chloride test for estimation of chloride ion. So how it is used? Just remember that potassium dichromate, when any sodium salt is given, any chloride salt is given to it, it forms chromyl chloride, right? And this chromyl chloride, in basic medium gives you yellow color solution of chromate. Yellow color solution of chromate. That means this particular reaction we use, right? Where we react, the Cl negative ions are reacted from the salt with potassium dichromate to form chromyl chloride, which on basic mediums give you yellow color of chromate, right? Okay. Then we say potassium dichromate in peroxide in acidic medium gives you CrO5, which has a butterfly like structure, and in this case it has +6 oxidation state, +1 here, +1 here, +1 here, +1 here, +2 here. So in total +6 oxidation state, and it exists in deep blue color, right? Okay, it has a butterfly like structure. Then some other reactions are that with peroxide and OH negative, this was in the acidic medium. Then in the basic medium, it is converted to K3OCrO8. In with HCl, it is directly converted to CrCl3. This is also a very important reaction. In concentrated cold H2SO4, it gives you CrO3, that is red in color. In concentrated hot H2SO4, it gives you Cr2SO4 thrice. Okay, these are all the reactions maximum that they can ask you. This way Ag positive forms this color, that is red. This after heating gives you dichromate ion, right? Then with carbon it gives you CrO3, right? Cr2O3. This Cr2O3 when it is reacted with, wait a minute, potassium alum should, chromium alum should be here. Dichromate reacts with H2SO4 with SO2 and H2, it gives you chromium alum, right? Just like you have fitkadi, na? Same way. Color of KMnO4, and this is due to ligand metal. Now we say, see, this is in D0 configuration, this is in D0 configuration because here chromium is +6. Here manganese is +7, both have D0. Then DD transition does not play a role. So they give the color because of charge transfer. Okay, Ji. Tell me everyone, is that clear? Let's see and do the questions, and I think then we will be done. Okay? Yes. Tell me everyone, let's do the questions and I think then we will be done. Let's do the questions part. Yes, everyone. Let's do this. Okay, just give me 2 seconds. I'll just come back. Just give me 2 seconds. Okay, so let's do this. Let's do the questions part now. Shall we start, everyone? Shall we start? Let's see. Okay. So, first is consider the following statement about manganate and permanganate ions. Identify the correct statements here, right? So let's talk about this. First is the geometry of manganate and permanganate is tetrahedral. That is correct. Okay, so A has to be there. The oxidation state of Mn is manganate and this is +7 in this. See, in manganate it is +6 and in permanganate it is +7. So they have written opposite, so this is false, right? Oxidation of Mn2 positive by per diaxo gives manganate ion as the final product. That is also not correct. If you talk about this Mn2 positive salt by per oxo disulfate, this we have talked about here. If you see this, we have talked about this reaction here. Wait a minute. I have talked about the lab preparation. It gives you permanganate ion, right? Mn2 positive with dioxosulfate, right? So answer is this also statement. This statement is also not correct, right? They are saying they give manganate ion. It gives permanganate ion. So this is also false. So only A till now is correct. Okay, B and C should not be there. So this is not correct. This is also not correct. D and E will have to see. Manganate ion is paramagnetic, permanganate is di. That is correct. So D has to be there. That is for sure. Acidic permanganate ion reduces oxalate, nitrite and iodide. Acidic. Wait a minute. Acidic permanganate ion. Oxalate we have seen in basic, right? If you remember, we have seen nitrite also in basic. Iodine it can do, but these two we have seen in basic. So this is also false. So statement A and D are correct. Okay? Statement A and D are correct. Option A is the right answer. Absolutely correct. Okay, now let's see the next question here. Let's see the next question here, that is, so they have given you two statements here. They are asking the number of pairs. So let's see everyone. The number of pairs from the following in which both the ions are colored in the aqueous solution is 3. Both the ions are colored. So here though you have to see colored ions means where if see in this case both the ions are not colored. See, scandium 3 positive is colorless, right? If I talk about copper 2 positive, it is still there, but titanium 4 positive, if you see, right? Titanium is what? Titanium is 4s2 3d2. So this is also colorless. This is also colorless. So only this you see is colored, right? This is only the colored. So they are saying number of pairs which both ions are colored, that is 3. No, that is false. So this statement is false. They are saying thorium 4 positive is strongest reducing agent among these. Reducing agent means which itself can get oxidized, that can increase the oxidation state. So they both cannot. Gadolinium is in the same. So europium can increase the oxidation state. Itself it can get oxidized and it can act as a very good reducing agent. So this statement is again false. Europium 2 positive is the strongest. So you can say both the statements are false here. Right? Okay. Next question is, the first ionization enthalpy of chromium is lower than that of manganese. First ionization enthalpy, yes everybody. First ionization enthalpy of chromium is lower than manganese. See, this you have to see it this way. This is chromium, this is manganese. Chromium is 4s1, 3d5, Okay, this is 4s2 3d5. You take out one electron here, it will be converted to 3d5. You take out one electron here, it will be 4s1 3d5. So it is very easy to lose electron here because it is getting converted to a stable form. So first answer, chromium is lower. That is definitely true, right? Second and third ionization enthalpy of chromium are higher. Second and third, if I talk about second and third, second will be 3d4. So it will, like, you have to be like, you have to take out electron from very stable state. Here you have to take out electron and it is becoming a stable state. So here it is low, here it is high. So that is correct. Wait a minute. Third, if you say you take out third ionization enthalpy from here, IE3. IE3 is going to be, wait a minute. IE3, if you take out from here, it is very tough. So ionization energy of third of manganese will be higher as compared to chromium. Okay, so this statement will become false. So you can say statement 1 is true and statement 2 is false, right? Okay, so statement 1 is you have to see it fully, that in the third ionization enthalpy you are taking out electron from stable, then chromium will have more. Sorry, manganese will have more. They are saying chromium will have more in both in case of second and third. No. For third ionization enthalpy, manganese will have more as compared to chromium. Okay? Chalo. Next question is on heating a mixture. Okay, so now this is again a reaction based question. On heating a mixture of common salt, NaCl, with K2Cr2O7 in equal amount with acid, gas is evolved. Okay, formation of gas evolved and oxidation state of sentimental atom in the gas is respectively. Gas evolved with chromyl chloride, Cr2O2Cl2. Wait a minute, Cr2O2Cl2 na, right? Okay, Cr2O2Cl2. This and this is wrong. This will be x minus 4 minus 2, that is plus 6. So answer is going to be C is the correct answer. Next question, guys, again statement based question. Again statement based question it is. Let's see. Mn forms oxide Mn2O7 in which manganese is the highest oxidation state. Manganese is in plus 7. It forms an oxide, that is this. It is in the highest oxidation state, that is true. Oxygen stabilizes manganese in the higher oxidation state by forming multiple bonds. Yes, it has MnO, Mn and 3 bonds, multiple bonds are there. Like this. This is the structure, that is also true. Wait a minute. That is also true. Manganese, wait a minute, I am not able to see you guys again. Okay, wait a minute. Okay. Mn2O3 is ionic oxide. Is it ionic oxide? No. You can say it is covalent. So no. The structure of this consists of one bridge oxygen. Yes, it does consist one bridge, this MnO, Mn. So A, B, D statements are correct. That is B will be the correct answer here. Okay, B is the correct answer here. Next question, guys. MnO for an acidic medium disproportionates into which thing? Permanganate ion in the acidic medium, it disproportionates into which thing? Manganate and MnO2. So answer is going to be B is the correct answer here, right? So you can see a lot of questions they are asking from here, right? Next question is, among the following 3D elements, the number of mixed oxides of the following are what? Right? They have asked you a question on mixed oxides here. Mixed oxide. See, titanium does not form. This does not form. Manganese forms. Iron definitely forms. See, one is Fe2O3. Huh? This one Fe2. Huh? This one forms. This is the +3. No? This does not form. This forms. So cobalt also forms. So there are total 3 mixed oxides here. Right? Okay, again factual question here. Right? Then next is, I think 1, 2, how many questions we have in the end? 1, 2, 3, 4, 5, 6. So many questions we have, some 8 questions we have, right? So let's do it one by one. Consider the following reaction sequence. JEE 2026 question they are asking. Consider the following reaction sequence. Yes, everybody. I think this is the second question, like that is something similar. Dichromate with NaCl, it forms chromyl chloride, CrO2Cl2. Then this in NaOH, that means NaOH, it gives you B. Chromyl chloride with NaOH means basic, it gives you dichromate ion. This B is going to be what? CrO4 2 negative, dichromate. This dichromate in acidic medium with H2O2 gives C. That is actually CrO5. Okay, because so many important reactions that I told you they have asked. In the product C, they are saying in the product C, okay, X is the number of O negative, O2 2 negative units. Let me Y is the total number of oxygen atoms present and Z is the oxidation state. See, it is having this kind of thing, this kind of structure. Okay. Then X is the number of O2 2 negative units that you have. O2 2 negative, you have 2 units like that. This is O2, O2, both are 2 negative. So 2, Y is going to be 2. Y is the total number of this. Z is the oxidation state, that is +6. X plus Y plus Z. Z is what? Acha, Z is +6. Y is this. X is what? X is, acha, X is a number of O2 2 negative. This is going to be 2. Y is the total number of oxygen atoms. That is 5. So it is 2 plus 5 plus 6. That is 6 till 13. So answer is going to be 13 as the correct answer. Yes, everyone? Yes, 13 is the correct answer. Then they are saying among scandium, manganese, cobalt and copper, identify the element with highest enthalpy of atomization. With highest enthalpy of atomization, the spin only magnetic moment value of element in +2 oxidation state. Highest enthalpy of atomization is in which? Yes, tell me guys over here. Scandium, manganese, C. Here they are not given in 3D elements. Out of this you have to pick. So in this case, cobalt have highest enthalpy of atomization. Right? Now they are saying identify the element with highest enthalpy, the spin only magnetic moment value of element in +2 oxidation state. Cobalt is 4s2 3d7. Right? Cobalt 2 positive is 3d7. So in this case, the spin only magnetic moment 10 minus 3, number of unpaired electron is 10 minus 7, that is 3. So it means mu is going to be 3.9, that is approximately 4. So answer is going to be 4 is the correct answer. Yes, everybody, tell me. 4 is the correct answer. Now next question. Next is also same that they have given in 2025 as well. This is compound A that reacts to give chromyl chloride. See, chromyl, this definitely is dichromate, K2Cr2O7, right? Then this reacts with this to give B, that is chromate, CrO4, 2 negative. This in acidic medium gives C. Chromate in acidic medium. Chromate in acidic medium will again give you dichromate, na? Cr2O7, 2 negative. Now number of oxygen, terminal oxygen. Now if you see Cr and this is Cr. Double bond O, nahi. This is O, O negative, double bond O negative, double bond O. They are saying terminal oxygen present in Cr what? Terminal, how many terminal oxygens are present in C? Tell me. Everyone. How many terminal oxygens are present? This one, this one, this one, this one, this one, this one. How many? There are 6 terminal oxygens are present, okay? One is bridging here. Next question is the molar mass of water insoluble product formed from the fusion of chromite with Na2 is in presence of O2 is what? See, if you have chromite ore in this, it forms CrO4 2 negative. Okay? Okay. Am I the only one answering 6? No, I am also answering 6 only. Wait a minute. This is actually a lengthy question, right? 1, 2, 3. Chalo, we'll do this. We'll do this then. Molar mass of water insoluble product from the fusion of chromite ore with Na2CO3 in O2 is actually chromite ore is Cr2O4 plus Na2CO3 plus O2 is actually Fe2O3, right? This is actually Fe2O3 that is formed here. That is the insoluble product that is formed here. Okay. Now we have to talk about this fusion of this with Na2CO3 in presence of this is what? Molar mass. You have to find out. Now you just find out the molar mass here. Simple, right? Just find out the molar mass and I'll just give you the answer here. The molar mass in the end will come out to be 159.6. Okay. Molar mass you can calculate by just adding 2 of Fe plus 3 of this and it will be 160 approximately. So answer will come out to be 160. Okay. Molar mass only they asked. Then niobium and ruthenium have X and Y number of electrons in their respective 4d orbitals. Now they are asking you niobium and ruthenium, right? So for that you must know the electronic configuration of niobium and ruthenium. Okay, niobium, ruthenium. This is D4S1. This is D7S1. Okay, so they are asking you why number of electron respective 4d orbitals, that is 4 plus 7. That is 7, 8, 9. This is 11. So answer will be 11 is the correct answer. Right? Okay. So these are electron directly from the electronic configurations they are asking you that I told you in the starting. D block starting, okay, that these electronic configurations are exceptional. So correct option with the order of melting point of pair of this. Melting point of pair of this, beta, you have to tell, right? Melting point of pair. So firstly, between osmium and rhenium, what is the answer? Osmium has less. Okay. Then between technetium has less. Yes, technetium definitely has less. So this is also ruled out. This will be the answer. Manganese as iron, definitely manganese is less. So answer will be D, because technetium and manganese you see a drop. Okay, that is how we know manganese and technetium will be low, right? Okay. Now next question is, consider the following reactions. These reactions are given to you and they are asking you A and B here. Dichromate in acidic medium, then that one in basic medium. Dichromate in acidic medium, then that one in basic medium. So if you see dichromate in basic medium, dichromate exists in acidic medium. In basic medium, it will be converted to chromate, that is this one, K2Cr2O7. After that, it will be again in acidic medium, will be converted to dichromate, that is this one. So answer is C is the correct answer. Next is identify the following. Now they are asking you statements, correct statements. Okay. Chromate ion is square planar. Chromate ion is square planar. No, tetrahedral. Dichromate are generally prepared from chromates. Yes. The green manganate is green manganate. See, both of them are chromium 6 positive only. So both of them are diamagnetic only. Dark green colored K2MnO4 disproportionate into neutral or acidic medium to give permanganate. Acidic medium it gives. Okay? Permanganate ion. Okay? In acidic medium it will give you permanganate ion. Achha, they are saying green color manganate. I'm so sorry. They are saying manganate ion, beta. I thought chromate ion they are saying. Manganate ion means MnO4 2 negative. Right? That simply means Mn plus 6. That simply means D1. That is not diamagnetic. That is paramagnetic. Dark green color, this disproportionate into give permanganate. That is correct. With increasing oxidation number of transition metal, ionic character of oxides decreases. That is also correct. Right? So answer will be B, D, E are correct statements here. Right? Then next question, I think you can easily answer this one. You can, or I can just give you for this for homework, right? Because it is very simple. I can just give you this one for your homework, okay? That is, they are saying NaCl reacts with this multiple times. We have done this, so you can easily answer that. This is for your homework, right? This is chromyl chloride reaction, okay? Understood? Yes, everybody. Tell me. Tell me. Okay. Now, crowd was very less today. That was very unexpected. That crowd was so less today. So I'll see how many of you are interested in only the question practice of physical chemistry. If you are up for that, then do let me know in the comment section. Also share this with your friends so that even I get motivated to take these sessions, right? Okay. Yes, everyone. Okay. Okay, then bye bye. Take care. See you all in the next class. Do let me know in the comment section if you want me to take up the lectures for physical chemistry or not. Yes. Okay, then bye bye. Take care. Bye bye. See you all in the next class. Bye bye. Very good. Navneet, Kantha Rao, Tejaswini, Dilda, BCM, Pi. Very good. Awesome. Chalo, now I'll see you all in the next class. Bye bye.